Okay, so here in demo 3, we're going to talk about ellipses and how we can build on what we've already demonstrated to create accurate ellipses on accurate squares in 3D space based on our perspective view. So before we do that, we need to handle just a few theories about ellipses. So let's come over here real quick. And we'll just do a little bit of diagrammy stuff. And we want to do this in orange, of course. Okay. All right, so what is an ellipse? An ellipse is a circle in perspective. Okay, so here we have our circle. Great. Okay, so here we have a circle. All right. And at the center, we obviously have the axes point. So if you kind of think of that like the hub of things, all right? So an ellipse is like this, right? And we would sort of consider this an ovaloid or an oval, and that's true if it were laid flat and it were just this shape, even if it was flat against a plane, it would be an ovaloid. But we want to think of this shape as being in perspective, meaning it's laying on a flat ground and its edges are converging to a vanishing point or more, and the center of it is sitting, the perspective center of it is sitting here, allowing us to rotate around it and to do various types of scaling and beveling and all the detailing we want based on that information. So it's not just an oval. And so we can't handle it like an oval. But there are definitely things that we can take into consideration right off the bat. So let's go ahead and stroke this here. Okay. All right. So number one is that let's grab this and we'll delete this one now. And let's just see how it's built. All right. So if I take a square here, since we're building on a square, and we'll go ahead and stroke that one as well. All right. So we have this square and a circle like a square. Whoops. Let me get back into my ellipse marquee. Okay. So a circle like a square has even measurements on all sides. So I can literally use a square like this as a pattern. All right. So let me stroke that. So now I have a circle within a square and it's even units. Okay. And what that allows us to do is things like this, where I can grab it and I can go 45 to 45, right? Just like we did normally. Whoops, that one did not snap. So we'll go from here to here. Okay. And we can find the center of the circle. All right. So when this circle is laying on a plane and it is being subjected to perspective, meaning that these edges, for instance, are converging to a vanishing point, that this circle is going to like go with it. Okay. And will generally move towards the convergence, so away from the literal center and into convergence. Okay, so that's when we would get things like this, where it's laying down. And this would be the literal center. So let's go across the long way here, like this. And then, of course, we would have here in the middle, I think I'm a little to the right, but you get the point. All right, so this is the measured divisions, both long way and short way. And across the long way, we call this the major axis. This is the major axis. And of course, across the short way is the minor axis. Now, when doing doing ellipses in perspective, the minor axis is the governing thing that you need to consider the most. It has the most impact on the degree of the ellipse and how we handle these things. But that doesn't mean that the major axis doesn't have its role. It certainly does. But I have seen different sources of information say you can pretty much ignore the major axis as long as you understand the minor axis. And I would say that if you look at it like this in particular, and you say like this is a wheel, okay, and this would be kind of like the axle of the wheel. And so if you think of the axes, the minor axes in particular, as like the wheel or the center of rotation of your ellipses, that's going to tell you a lot about the nature of your ellipse and how you need to handle it. Okay. So with these sort of like thoughts in mind, we can start creating ellipses in perspective space. Okay, so we do need to know the difference between the perspective center and the literal center. So let me go ahead and hide our cube here for a minute, and we'll just do a quick and dirty ellipse in perspective. Okay, so I'm going to go ahead and I'm going to throw a line here like this. Okay, so this is a line, and we're just going to be in like 1 point perspective here. And let me grab, this is my ellipse tool, but I want in particular, well, did I not have? Okay, all right. Well, it looks like I must have got rid of my guide from, so we'll just go like this. And we're going to take this all the way up the center of vision to our horizon line. Oh, never mind. I know I did. Okay, so this is our horizon line. All right. So we'll just put these out here and we'll edit them in just a minute. Okay, so if I take my ellipse tool, I will set it right here in the middle of my ground plane, and I'm going to origin from the beginning, so we'll radiate from the middle, and I'll go ahead and do it even like this. So we're going to say this is a circle in perspective. All right. So let's go ahead and stroke that. Okay, great. And what I can do now is I can just grab these handles here and I can touch the edge of that like that and touch the edge of that like that. Okay, fine. All right. And what I'll then do is, since I have this center of vision and this is in the center of our world, it's really easy to measure. So I can just grab the bottom of that ellipse right there and go out and out. Oh, I know what I'm doing, sorry. I gotta stroke this. So we're gonna say edit, stroke, fine. We'll drop that. All right, there we go. All right, so now we're gonna go from there and from there and there and there. Okay, so now we have this this bounding box around our ellipse, which is a circle in perspective laying on the ground. So if understanding that theory that a circle fits perfect measurements within a plane like this and it's square, we can assume then that this is a square. All right, so ellipses are a pretty good way to find squares, but also squares are really great ways to find ellipses. Okay, and if I x across, using the x method again, across and across, what I have here is the perspective axes, right? This is the perspective center of our ellipse here. Okay, so this is really useful to know, especially when you want to start turning things. You could use this ellipse kind of like a dial and start turning things in degrees, et cetera, et cetera. But to find the accurate angle of your axes, you're going to need to know the actual literal center, and we'll go ahead and we will use this tool right here. We want to come right across here like this. Like this. Right to the edges of that ellipse on all sides. And I've got it, sometimes I've got to edit here. So I'm just going to select transform selection. And we'll get it a little bit closer here. And I'll snap this here to the edge of that ellipse, make sure that's all squared off. So what you can see here is I've got the actual height of our ellipse here. Okay. And so imagine now it's not in perspective, it's just flat. Okay. And with that, yeah, we're pretty good. Pretty good is good for demonstration, but not necessarily good for product. Okay. All right. So the theory is true. Okay. So the bounding box of this square now has the height and width of this ellipse, but it's perpendicular to, sorry, not perpendicular, it's parallel to the picture plane. And what you can see is we have these little handles that are in the center, handles in the center, and then of course in the middle we have this little origin point in the middle, which would be, this is the literal center of the oval that makes up our ellipse. This is the literal center. And you can see the difference between the literal center and the perspective center. The perspective center is off because I've got this line over here that's a little off of my angle, which is causing it to float to the right. But it should be here in the center of vision. Okay, but you can see the difference between these two. So this is the literal center, the measurable center of that shape that is the oval, and then this is the perspective center of this ellipse, which is a perspective shape on a ground plane here. Okay, so it's important to understand those differences, and when we start putting ellipses on faces and using perspective tools to put them in space, we will need to understand this, because the actual major axis, if you remember, goes through the perspective center, not sorry, it goes through the actual center, not the it goes to the perspective center. Oh, I went too high. Not the, sorry, it goes to the literal center, not the perspective center. So when we start using ellipse tools that have indicators for major and minor axes, you want to make sure that you're running through the literal center and not the perspective center when you are creating those. You need to be able to turn those tilts. So that's all very, very important information to have as you're creating ellipses. Okay, so let me come back here and we will drop this like this. Okay, and drop this. All right, and we're going to bring back our cube from the last demo right here, this thing. And since we know this is square, it's a cube, so we know this is square, we know this is square, we could use either one of these faces to create an ellipse. We have that information here. All right, so what I'm going to do is I'm going to go ahead, I'm going to take this, and I'm going to just put some measuring information on here for us. So I'm with orange, I'm going to come back here and I'm going to find the perspective center of the face of this cube. So using the X method. Okay. So where this crosses right here, that is the perspective center of our cube face. Okay. And since I am in 2-point perspective, I can take this line straight up like this and back down. Okay, and I've got that measured. Now I can't do the same thing here because this face is in perspective, so that means I have to come from my left vanishing point over here. So vanishing point left, so I should be using blue, and go right through that center point right there. Okay, so now that vertical and horizontal in perspective has quartered off this face. All right, And so they're all even units. We have the 45 degrees. Everything is meeting in the center right there. Okay, so as I said, the most important thing that we need to know, though, for our ellipse is the minor axes. So if I grab this red here like this, I need to come from vanishing point right, grab it here, and it's got to go right through that perspective center, that hub. Okay, so this now becomes our minor axes right here. And I'll just go ahead and annotate that. Okay. So this is our minor axes. Right there. Okay. For this face. Okay. If I were creating the ellipse on the right face rather than the blue face, the right face rather than the left face, then I would go from vanishing point left through the perspective center of that face. All right. So now we've got some pretty good information that we could use. But we need to find a few things. We need to find the literal center of our minor axes line. And we need to start talking about what's going to restrict our ellipse here. So if I come up here, and since we're on the left face, I'm going to create blue lines. Blue for left, red for right. Okay. And so I'm going to come over here, and our ellipse is going to need to go through here. So through this point, it's going to need to go through this point where those two orange dots meet, lines meet, this point, and this point here. It's going to need to go through all of those points around our space. Now, after you've done a few hundred of these things, you're going to be pretty good at just throwing them fairly accurately, and you can tie them down in a program later. And there are other tools that you can use to try to get that accuracy there. But we're going to use this technique and some tools to show you how we can better utilize this. Okay, so if I come back here into my paths tools, where I just have like a bunch of these different things, I'm going to go ahead and I'm going to duplicate this right angle tool, and I'm going to use it. So if you remember, I had that set at our station point so I could find our vanishing points. Okay, so they're right here and right here, and it's a 90-degree tool, and it's very, very useful. So I'm going to go ahead and shrink it down. Okay, and I'm going to use it to find 90 degrees relative on our minor axes. All right, so if I come up here, and I'm just going to set this right here at the hub for the moment. Right here, I'm going to rotate it from that point. Okay, and so if I grab in Photoshop, if I option grab this little origin point, and I put it here on the corner, right where that thing meets, that's going to allow me to do any sort of translation, scale, rotation, etc. from that point. All right, so I'm going to go ahead and I'm going to conform this left arm of that right angle tool right along that minor axis. Okay, so what that says is this is 90 degrees, so this arm right here that's going up is in 90 degrees, and it's pretty close to our literal center of face. I mean, my minor axis is running kind of parallel, not exactly. There's definitely some convergence, but it is running pretty close to our vertical, which is really nice. Okay. All right. So the next thing I need to do is I need to find the actual width. Remember that an ellipse is also an oval, right? And it has its actual center and a perspective center. So we need to find the actual center, and to do that, we need to find the literal width of this minor axis as it rolls through this face. So from this red point to this red point, there's going to be a center point, and it's going to probably be somewhere on the right hand side of our minor axes here. So this is our minor axes, sorry, our perspective center. So this is the perspective center. And remember I said our perspective center generally pulls towards our convergence. And since the left-hand edge of this cube face is converging to our left vanishing point, that means that probably our literal center, our measured center of this face is actually going to be on the right-hand side of that. Okay? And so what I'm going to do is I'm going to grab, I have this little proportional divider tool that I use here. And these are just paths that I've created that allow me to, come around and mess around with these things and measure things. And it just is they're just really handy tools that I use. Okay. So I'm going to grab it, and somehow I've got a whole bunch of everything. Maybe this one will let me grab it. Okay. This one, T. Oh, I was on multiple faces, that's why. All right, so grab that one. All right. Sorry about that. Okay, so if I come here, and again, I want to stay pretty parallel with my picture plane. Okay, so I don't want to necessarily be rotating this thing around because I'm trying to find the literal width of this, right? But there does need to be a little bit of rotation because of just the angle of this minor axis, all right? And again, we're trying to find the literal center of this. So if I go ahead and grab this and I put that point there on the right-hand side of where the minor axis crosses that face right there. And then I can scale this edge here to where it hits the right-hand side of that face. That's going to give me this point right here, which is our measured center. This is the measured center of, that's the measured center of this face. Okay, so let me go ahead and do this, and I will mark this right here. So that's the measured center of what will eventually be our ellipse. So again, this is our perspective center. This right here is our perspective center. This is our literal center. Okay, and that's really, really important. So coming back to our right angle tool, this one here, looks like I moved it. It's fine. It should be at the right angle still. All right. So now I can come along this point, and again along our minor axis that we've already set up. So the angle should be right. And if I hit it right here at that literal center, like that, then what that's going to tell us is that where this line goes up, see this arm of this tool goes up, and it looks like it's going right through that 45 line. Totally coincidence, by the way. So if I grab this here then, and I mark it, so right here is where my major axis is going to intersect that edge there, and that's going to make this a pretty easy ellipse to find. So if I take my my line tool here, and I don't even need that right angle tool anymore. It's served its purpose. So I can just go from this point with this straight line. You know what? Let's make that smaller. We'll make this a 3-point width on this. Okay. So if I come right through this here, all right. So we're originating up there, and we're going right through that minor axis at the measured center, 90 degrees relative to the minor axis degree, right there. Okay. So that is going to be the major axes of our ellipse. Okay. That's the major axis of our ellipse right there. So we know where our minor axis of our ellipse is and our major axis of our ellipse, and we know the bounds that it needs to be. So that makes things fairly easy. So if I come here to this thing that I've made, which is our ellipse tool, which is also very, very handy, you can see that it's already rotated. So if I try to start manipulating this thing and like squishing the sides and everything, it's going to get really, really kind of like skewed in its angle. So I'm just going to go ahead and center it up against where some of these guides cross, and that'll allow me to to kind of recalibrate that ellipse tool. All right, so now it's recalibrated. You can see like these things are centered up, that's centered, which is nice. So I think this, if I remember currently, this ellipse is at like 66 degrees, but we don't need to worry about that too much. All right, so if I come here then, I need to center our ellipse at this point right here. That is our measured center, remember? And then I need to take, I can go ahead and shrink this down like so, and try to kind of get in the ballpark here. Okay. And now I want to tilt this. I want it so that these outside ticks are going to be at the angle of my minor axes right here. Okay. And then these are at the angle of my major axes. And we're pretty close. We're really close on this already. So we just have to make sure we're matching the degree. Okay. That's wanting to snap, so we got to get in closer on that. Okay, yeah, we got a lot of guides up, so there's just a lot of snapping happening. Okay. All right, so that really should be right in there. And you can see that major axis following that blue line, and this one here, we're snapping. And you can see how this is running parallel to this. Is it perfect? No, it's because I'm just really in there close now. So these things are looking a little off, but they will definitely be passable for this. Okay. But we definitely want to be as accurate as possible. So you can see this is still running parallel to this. Yeah, and if we come back here and we look at our origin point, look how close it is to that. So there's a few measurements that are a little off somewhere, probably in a few places, but they're all really, really close. So our major axis is running through that blue line, our major axis angle. Our minor axes are running parallel to, probably getting a little bit closer, parallel to our red line. It should be running right through the middle of it, but again, I think I have a few measurements off somewhere. So we could probably tighten it up just a little bit like this. Probably is all it needs. And again, some snapping. Okay. So just be perfect, guys. That's all it takes. All right. All right. So other than some minor little ticks of it or whatever, now this ellipse is perfectly flush on this square, right? So this is an ellipse in perspective. So I can come over here. Let me go ahead and command click this icon for my ellipse tool, which creates a selection radius. I'll go ahead and create a new layer there. And since it's left, we'll make it blue. So we'll go edit stroke, and we'll stroke that selection. And I'm going to actually save that selection as well, because there's a decent chance that we'll use it over and over again. So I'll go ahead. I'm going to save that selection there. And if I drop it, you can see now that this degree of ellipse matches that face on that cube. And so if you're creating something like a really big sci-fi structure and it has a really cool ellipse detail of some kind or some mechanics, whatever, all you need to do is find your square and perspective somewhere on that face using the tools we talked about in the last demo. And then using the techniques that we talked about today and these tools, you can place that in this face like this. You can get an accurate ellipse in there and it will work. Now, as long as we're on this face, we can pretty much scale it from the center. Okay, so let me go ahead and grab a duplicate of that ellipse. So we want it from the perspective centers where we want to scale it from. Okay, so if I grab that then, and I want to transform it, so let's do a transform, and I'm going to move this to the perspective center now, not the measured center, because we want to scale it in perspective, right? So if I do that and I just hit Option and come down on it, you can see that we're getting an accurate inset on these, okay? And that's pretty nice. Yeah, so we can create really cool details, all right? I can even shrink it down and then say I want to go back in depth, so maybe this creates a hole in the side of my box, okay? So I can grab it. I'm going to keep that perspective center. Oh, why isn't that moving with it? Huh, weird. I don't know why that's not moving with it, but let's grab this. Oh, I gotta hit that return. That's why. All right. And if I keep this, moving in the direction of the minor axes, see now you kind of get this really nice, like impression here. Okay, and I can even take it all the way in like this. So now I've got kind of like this bevel inset, which is really, really nice, like that. And I can clip off the back end of this, and it'll look like a hole in the face of that, And I can even draw a line from here to this, and measure it all the way back, and I can create radiuses that go on there. So I want to talk about that just a little bit. All right. So let's say then that we have something like this, and we want to get accurate slices, right? That radiate from the center, the perspective center, and they're even slices, and we can use it to create things like nozzles and domes and all sorts of things that are really, really interesting details. So I'm going to need to be able to project from this edge to a point ahead. Okay, so let's just say then that we'll go back to orange for this one. Actually, we'll go to green on this one. All right. So let's say I wanted to create a cone. This is the base of the cone against this face, and we wanted it to extrude from the center, so it's going to go through the minor axis to do it. And let's say we want it to go like to this distance right here. Okay, we want it to go there. Well, as long as I come from the edge of this ellipse anywhere and converge there at that same point along that minor axis, like this. Okay. Then we can get that feeling of that convergence, right? So let me grab this one here. I'm just going to grab this edge here so I don't have to worry about what we don't see beyond that. So let me grab one right here. And so you can see that it creates that convergence in perspective automatically because we're just following that minor axis right there. Okay. Now these radials are not uniform, and we're going to actually use the same idea of reference points and measuring points to create accurate convergence, accurate divisions in this, so that it looks really, really nice. But as we back up, you can see like that's now a cone, almost like a drill, right? That's coming out of this face, and that's a very useful thing. But let's say we want to make this uniform first, okay? And so I do have another tool. Let me go ahead and get rid of. Let's keep that. I want to get rid of this and this. Yeah, we don't need those anymore. And I don't necessarily need the xing right now and the minor axes. I don't need that. So I'm going to go ahead and note that layer. So I'm going to call that minor axes right there, just so I can come back to it when I'm ready. All right. So I want to use the same concept that we did with the measuring points to find an accurate division of this pie slice. It'd be really easy to say, okay, I'm going to go from north to south and then use my perspective from my vanishing point across here. Now I've got it quartered, which is true. And then once you try to start eyeballing lines through the middle, you're going to start getting off in the degrees. They're not going to match. So I've created another tool here, which is my 20-degree radial tool. All right. And the reason why I use it for this demonstration is, as you see, this line right here does go north to south, or vertically evenly splitting in half. But you'll notice that we do not have a horizon line that cuts in half. And that's on purpose for this demonstration. Like, I could have used a measurement that did cut it in half, and that would have probably been a little bit easier. But I wanted to use this to show the concept here. All right. So we're going to do measuring points or reference lines. And so if I take this face, now remember, if I had this box here, and I'll just scale it down so that it's as tall as my box is. So I'm going to come right up here. And let's just put it right flush on that hinge like this. Yeah, that's pretty good. Okay, so like again, if you imagine when we were doing the measuring point demo, this face of this box swinging until it ran parallel with our picture plane, it was flush against the picture plane, that it would be a square, right? And so you can almost imagine this kind of like a door swinging back into perspective, right? And so we want to be able to catch all of these elements, these here, on this face, okay? So the easiest way to do it would be to take it on the opposite end. So I'm just going to go ahead and grab this, and I'm going to move it to the other face. So this line right here, okay? And just like we did with the measuring line before, drafting lines that we can then use perspective tools to create, we're going to do the same thing here, okay? So I have this tool, and I'm going to use orange for this. So we're going to go back to orange here, okay? And I'm going to come over here to my new layer, this one, okay? And what I can do then is I want to kind of like find out where these radial points from the center hit the edge here, drag them horizontally across until they meet this plane line. Then I can use my perspective tools to find out where they fit on this. Now I only have to get half of this ellipse, because once I cross these through the minor axes, they'll match the other side. Okay, so I'm going to go ahead here and with my pencil tool, I'm going to go ahead and I'm going to set right there, and then boom, to where it hits that edge. Here, boom, hits that edge. And I'm just thinking a little fat with that pencil. Here, boom, let's get a little bit closer. Here, see, that's almost like just absolutely, that's so close right there. It's going to be really easy to find that. All right, so I'm just going to go along any face, any of these points that match that face. So this one's really close, right? See, it's outside that face, but it is not outside that face. All right, so now that allows us, see that? That allows us all of these points here to meet what I need. Okay, so let me go back to turn my minor axes thing back on. All right, we no longer need this face, but I will say this before I click it off. This ellipse template here that I've got, the radial, is that if you had it converging, upwards or downwards rather than like we do here to the left, you would maybe want to put your template with your radial on the bottom or the top rather than the side. In this case, it works fine. So whatever edge tends to be working parallel to your picture plane, that's where you would want to flush it up against. Obviously, I don't want to flush it against this unless I'm using the measuring points, and that's just going to give us an extra step. So I didn't do that. All right. So I'm going to go ahead, I'm going to turn that thing off, and what I'm going to do instead now is I'm going to turn my vanishing point rubber band tool on. Now remember, with this thing, that I have this center point here. I'm just going to leave it centered along this spine here, and each of these edges, this line is going off and it's locked down to my vanishing point right, and this line is going off and it's locked down to my measuring point left, or sorry, my vanishing point left. And so I know that I've got like perfect degrees on this. So I can come up here to this line here, and I don't have to draw all these lines. All right. I just need to do ticks on this. And so since we are on the left face now, I can go ahead and go back to blue. All right. So now I want to start thinking about where these go. So I'm going to try to get right in the middle of this like this, and I'm going to put a tick there. All right. And then I'm going to come down to the next one as close to the middle as I can. And I'm going to put a tick here. I am kind of thinking about the how it radiates already. All right. And here. And I'm going to put a tick here like this. And then here, see how close this one is. That's easy money, right? Right there. Okay. And then just all the way down here. Okay. And here. Okay. Two more. And here. Right there. Okay. There we go. All right. And then of course we do have the one that runs north to south, and that's the easy one since we literally already have that line there. All right. So now all I need to do is I'm going to go ahead and grab a new layer here. I'm going to go ahead and start using my line tool, and I'm going to run that first one north to south, which we already know that's a given. Okay. All right. And now as long as, let me get in here, and we'll go 150 so we want to be able to see this whole face, but we want to be far enough away. Yeah, that gives us enough. All right, so we can see the entire ellipse. All right, so I'm going to go ahead and start at this point right here, and it looks like I've got some snapping there. So let me remove, I don't know what that is. I'll probably regret it later, but who knows. All right, so I'm going to go ahead and grab that. And as long as I run through the perspective center, and hit the other edge of the ellipse, so if I run through the perspective center and I hit right there, that edge, then I know it's going to be divided evenly. All right, so I'm going to go here. I'm going right through the perspective center until I hit the other edge of the ellipse, like that. Okay, and we'll just do this all the way through. And again, remember, we only had to measure half of it because that straight line, as it goes through the minor axes or the perspective center, then it will copy it exactly. Okay. Now, this is really, really useful when you want to start doing things like tires. You know, if you want to start being able to do like really cool rims, spokes on a bicycle, all that kind of stuff, and you want to divide things evenly. Okay, so take that right there. All right, and okay, so I can hide those ticks. We don't need them anymore. We already projected them. Okay, that's our ellipse. Take our minor axes, we can hide it. So now all of these are divided evenly. They're all 20-degree slices around there, which is really, really nice. Okay, so I can do a lot with that now. And you can make it whatever degree you want. It's up to you. And it just, you know, more slices, more lines. You know, less slices, less lines. So, but if you remember, we created a little tick point here along the minor axes. So if we wanted to project like that cone, we have that one cone. Where is it? This, right? Ooh, it's so ugly, right? And it's not really that accurate. Okay. So let me go up here and we'll mark it again. And this time we'll use our accurate spokes. So I'm going to come right here along my minor axes. I'm going to mark that point right there. All right. I'm going to hide these. Don't need them anymore. And I don't even need this minor axis at the moment because I know the target point, which is that point right there. And I know that it's already along the minor axis. So this is just kind of a way of me trying to keep this thing clean and make sense of things because it's really easy to start getting lost in all these lines. All right, so now if I just go from these points where they radiate, and I'll just go start actually from this axis point, and I'm going to see, yeah, that's probably the best one. Like I'm not going to catch these here because I don't even see through those. So I'm just going to catch this one. Yeah, there's probably actually one here I would need to catch too. So I'm going to grab that one right there. But you can see how the edge of that ellipse goes over. So I'm not actually going to catch this one. I can if I want to be really, really literal, but I'm trying to create like a cone, right? So I want to try to catch that edge right there. And I was a little inside on it. So let's get a little close. Okay, so I'm just going to catch this edge right here. Yeah, that's nice. All right, so here I am. I'm just going to go around this ellipse, and the idea then is that if I've done my job correctly, or at least passably correctly, then I should have kind of like this cone thing with even radius. I can see that already at my convergence point I'm being a little messy, and I would probably use guides to snap there because this is getting a little messy. But we can start cutting this thing up as well. We can actually take and extrude an ellipse along our minor axes and then start cutting into this nozzle and creating all sorts of really cool, like, again, almost like the cone of a satellite, you know, or a space station or any of that kind of stuff. Yeah. So that's going to lock there. And again, I don't have to do like the full other side because if this were opaque, we wouldn't see it. But I do want to catch the edge. So this one's going to snap over here, even though it's not snapping to this line. It will create like this is the object edge. And so even though it wouldn't be a detail line like these facets are, it is a holding line, which helps describe that form. So if I come back here to those radials and see now I knock them out, now I have, look at these are all even radials converging to this point here. And again, it's a little messy here at the tip, but you get the point. No pun intended. All right, so we can create that kind of stuff. And then I can start projecting out. If I wanted to, I could create a vertical line from, say, this one, since that's a vertical. So I create a vertical line from this line, and this one's the vertical as well. These two go straight up. Here, I can find a division point, create another ellipse right in there, and it would look kind of like a nozzle that's projected out, and I can cut it in and that kind of stuff. And that's a very useful, like, detail thing to do, okay? So what we learned here was some of the theory about what describes an ellipse. We learned how to identify how to place the ellipse against a face of a cube. So this is an even cube face, which is a square in perspective. And so we were able to use the minor and major axes and both the proportional dividers, so I could get the literal center of this face and the difference between that and the perspective center. And then we were able to use our 90-degree tool, our right angle tool, and our ellipse tool to line up our major and minor axes to get an absolutely correct ellipse along this face. Then we learned how to use measuring points that were projected from a template that was flush against this edge to project those little detail points here, and then use our perspective rubber band tool to line those up along that edge of that ellipse here and create accurate radials in perspective. So those accurate radials in perspective, and then using a projection point from our minor axes along there, we can create a convergence point and have those radials meet it, which creates a cone in perspective with accurate even segments along here. So these are all even segments. So it's kind of like 3D modeling the old-fashioned way, right? So that is our basic ellipse demonstration. Next, we're going to jump into doing blueprint plans of a vehicle, some of the concepts behind that, building out a bounding box for that, and then using the concepts of the measuring points and measuring lines to find accurate landmarks within those blueprints that we can then use to model a technical drawing with these tools. And we will use this concept that we did with this ellipse to do things like the headlights and the tires. And say you have the tires, but you want the front tires to be turned because it's a little bit more dramatic. So they're a little bit offset from like the rear tires to just give it that little bit more dramatic interest. How do we handle that concept? Okay, so there we go.